Okay, welcome everyone. It is 15th of October, and we if I can find the window, it's the usual thing. Hang on a minute. Let me get the right thing here. Sorry, I've got the wrong thing being shared. So Open Source Antibiotics Series 2. And the video is posted. I was just looking again at the video of the last meeting, and there was one person on the video and I didn't know their name. Had a mask on. I think it's maybe Northeastern person, had a mask on, blonde hair.
Thomas?
Say again.
Thomas?
Is it?
It was a guy with blonde hair.
Yeah.
Yeah, Thomas.
And how do you spell it?
I'll pop it in the chat.
Okay. Okay, just want to make sure I've noted everybody. And so we have some actions that I put up last night, which we can go through, which may take into account everything. So as I understand it, Dana, you've made that high priority toll compound already.
Yeah, that's all done.
Awesome, so that is ready to go, which is really good. So that can go into the next round, which you know we've kind of vaguely planned for the end of the month, and I will reach out to Paul to check whether he can do that. Just on that, before we talk about other compounds, I raised this issue about the activity ceiling, and I guess making sure that we're using an assay that was able to detect really active compounds, if indeed we had really active compounds, because we're really hitting that ceiling. So I guess when I talk to Paul about his assay, I need to raise the idea of him using a highly active control compound, positive control compound, which I'm not sure he's currently doing, from what I can tell from the data. So something which definitely would be expected to be more active than 2 micrograms per mil. I don't know what that should be. If anyone has any idea. Yeah.
Yeah, I'm pretty sure Alex has been using vancomycin as a control in her experiments.
Vancomycin.
So yeah, I think so. We can confirm with her next week, but I think she has been using it in that to sort of benchmark her stuff.
Okay. Okay, I mean, that would be fine, right? I guess I just need to raise that with him. And I was wondering if anyone remembered what the controls were that were used by COAD. Without digging through, I can't remember what they were. We could try and match that, but
That might also be vancomycin, but I'm not 100% sure.
I'm actually going to look on COAD's site right now. Maybe I think they detailed their testing protocol, right?
oh yeah.
Yeah, actually that would be probably on the series 2 repository as well, because
Yeah.
We had the protocols from them.
Okay.
So, yeah, we can find that information.
Right. So just before we talk about SAR holes, if we are going to try and aim for another evaluation of compounds by the end of the month, then the aim was really to see if we could secure any incoming compounds from Daniel and from Quillon and Laurie by the end of the month, kind of thing. That's kind of like just a target, so that we can try and arrange ourselves. So Daniel, you were busy with research stuff before, like report writing before, but we were talking about maybe being able to get some of the homologous compounds by the end of the month. Is that still realistic?
I'm planning to send to you next week, maybe 7 compounds. I finish 1 more this week. The reactions are working now. And I guess next week I could ship like 7 compounds, because I could make more compounds, but we should evaluate first if the scaffold is gonna work, and then if that works, the step that I need to work is just making the inoculation first, and then the managed reactions. That works well. I did it this week and worked well. I bought a few more iodine compounds, but then you should test the compounds, and then I could work better in the SAR. but I guess next week I would be able to ship at least 6 or 7 compounds.
Fantastic.
I can show you the scaffolds. Actually, I have the scaffolds here.
Oh, well, now.
Yeah, can I share
You
this?
wanna know? Yeah, fantastic.
I think that would be useful because I haven't seen what they look like.
Okay, just 1 second. It's 7 compounds if we count the intermediates, because I don't know if you should test the intermediates or not. Can you see my screen?
Yep.
Here I have, like, for example, I start to test the reactions without the pyridine in the imidazole portion. So I have those 3 compounds without the nitrogen here, and we have the CF3 group here. Then I have with the pyridine, and we have the N-alkylated managed product here. And now I'm working to have intermediate with 2-methylpropane, but I'm trying to alkylate the CF aniline having the CF3 just to have more variations in the main scaffolds.
Right.
That would be the next compound, having a CF3 in this I don't know if you can see because I'm pointing here with.
Yeah.
Okay, that would be the next compound, having a CF3 in the 3 position and methylpropane in the nitrogen. And then I could ship those compounds to you, and you could see if that's gonna work or not.
Okay, that sounds great. Yeah, I think the compound where your cursor currently is the key one that I guess everyone here would expect to be the most active, and all the others would be leading up to that. So still worth it, absolutely.
Okay.
Can I just check that the methyl in the benzo ring is in a different place in the pyridyl and the phenyl? Is that correct?
Yeah, the methyl group is different place. Yes.
Yeah, that's fine.
Have we tested compounds with those with methylations on the core?
Sorry, I didn't understand.
Can't remember.
I think we have a few one-offs from Northeastern.
Yeah, I think we do.
Yeah. I don't think they were active, but I think they had maybe they didn't have the 2-pyridyl or something. They had something, I don't know. I would expect that it would be fine.
My concern in this compound, it would be this methylene group linker here. If you have any problem with this activity, maybe this methylene linker doesn't work. Let's see which kind of results you're gonna have.
Yeah, but I mean that's what we're testing. That's exactly.
Yes.
All right, fantastic. Yeah, those would be really great. So yes, if those could be shipped next week, that would coincide with our assay, which would be really, really useful.
I will talk to you maybe Monday to get some information how I can ship, which address, and if I need to fill up some documents.
Yep, sure.
Okay.
Great. Okay, and then I guess last time we were talking about compounds that you guys had at Northeastern, which might be relevant to what we want to do, that could be shipped because you already have some. And I dumped some of those in. I took sneaky screenshots of your slides, Quillon. That's all right.
No, I'm sorry. I just realized I forgot to send those onto GitHub, so I'll make sure that's done today.
So these are, I guess, compounds that we were discussing. You were talking about the synthesis progress towards this guy, and then compounds like this that were ready for shipment. I mean, these would be obviously really great to have a look at if you had samples to spare. Did you have any other updates you wanted to mention about these compounds? We were looking at the CDD vault last time, and we were looking at the DMAP compound where we had the N-dimethyl.
Yeah, so I had a look through our stocks this morning, and I've got a little slide prepared for that. These 3 compounds here are already good to go. And on the slide 2 slides above that, there was one of the cyclopropyls that's in the 7 position, was synthesized yesterday and purified yesterday, but we don't have any QC on it yet. So the biotage looks like a good purification, so it should be fine. So that we'll be able to add that to those 3 that we could send whenever Laurie thinks it's a good time to send.
Okay.
That one's up to Laurie.
Did you say you had a slide to share?
Yeah, I did. Sorry, no, 1 sec.
Sorry, Matt, when you were talking about before getting compounds tested at the end of the month, are you like, when are you targeting? Because it's probably going to take, with customs, it could take about a week for the compounds to get there. So,
Oh, sure. I mean, end of the month, I was thinking.
so if we ship them out like next week.
Yeah.
Yeah.
Right. Ideal.
Done.
So these have a lot, these are all NHs, not alkylated.
Yeah, so these are, yeah, as you just said, they're all the NHs unalkylated, but there's plenty of stock so that all of these are able to be alkylated if there was any interest in them. The only exception obviously is this acetyl compound, which is good to send now if you're interested in having that sort of amide component in the molecule as well. And I guess this one is a match pair perhaps, so that you could match that back to the compounds Daniel's making.
Mm-hmm. Yeah.
But yeah, so this whole suite, we have like somewhere between 50 to 100 milligrams of each of these compounds. So there's more than enough to alkylate.
That's awesome. All right.
And I had my hands on them, so there are real amounts in each of these.
Okay.
Let's think. I mean, all very useful and interesting. And I can't really say that any of them are not.
I have a question about the one that's not substituted on the bottom. Could you do a Eschweiler-Clark on that and dimethylate it? That would knock out one of the compounds in the SAR hole table. The unsubstituted amine.
The third
This
compound
one here?
along.
Yeah. You think you could dimethylate that? But
Could just do a reductive amination with an aldehyde, with a ketone.
put 2 alkyl groups on there because that was one of the SAR holes.
What, not with nothing in that position?
No, aromatic 2 alkyl groups was one of the SAR holes.
Yeah, I think I know what you're talking about. So we have the aryl substituent, then they're then alkylated, but we don't have anything that's got like an alkyl.
So what kind of group?
But sorry. I mean, the closest would be, well, I don't know.
If you make it symmetrical, it's like pretty straightforward to make.
Yeah,
So
it might be interesting to look at. But we also obviously have never tested just the unsubstituted amines either.
Well, that one I have the most of out of everything. It's I didn't have a gram amount for you this morning, but it's half of an 8 ml vial.
Okay.
You could send it raw and dimethylate or diethylate it. That would be interesting.
I think it might be better to keep with the like methyl propane substituent. But Quillon, I was just going to ask, were you specifically looking for aromatic head groups? Because the other thing is we do have some aliphatic, and we could potentially have a look and see if we've got any of those in sufficient quantity to actually alkylate.
Yeah, so this is just a set that I went through of my own personal compounds that I had on hand. I was under the impression that you guys had previously gone through Antonio and Hitesh's compounds where we have those alkyls up the top.
I don't think we
really. Which position? Sorry, alkyls in which position?
In place of
aniline.
Okay.
Like we've got things like the T-butyl, the cyclopentyl. I'm not. Yeah, probably. We probably have a whole suite. We can certainly have a look and see if there's anything there as well.
Keeping in mind though that when you have the like bulky alkyl groups up the top, they tend to just eliminate out.
That's a good point.
That's how you make this compound here, is doing the one pot with the tert-butyl isocyanide, and then you just treat it with a little bit of acid, and that just goes away, and you're left with the HBr salt.
Okay.
The other possibility is if Dana has the she has a brominated intermediate, Buchwald Hartwig using Xanthos and an amine, disubstituted amine, like diethylamine, and then
yes, I thought about that. So I think we tested the morpholine, so we could make a few more. That one wasn't active, but yeah, that's another sort of possibility.
Buchwald Hartwig with the brominated with diethylamine and Xanthos catalyst.
So in my hands, I was never able to get the Buchwald to go when you have a bromine in the core. The reason I synthesized this compound was actually so that I could have the amine on the core and do a Buchwald to make this compound here. This went in about an hour, 95% conversion with the amine on the core. The bromine on the core doing the same reaction with the opposite partners never went. I'd get like a 5% conversion overnight.
What catalyst did you use? I mean,
all of them.
Yeah, that's interesting. Okay. That would be, so all these suggestions are very good, and it depends on the capacity you've got for doing some of these reactions. The alkylation reaction, I mean, I was thinking back to something Chris said at a previous meeting, where when the methoxy is on the pyridine ring, we increase the basicity of the nitrogen and make the compound potentially more soluble. So some of the ones in the middle there, I mean, the one on the right, for example, has the methoxy in the right place to do that nicely. And so I guess if we were thinking about alkylating any, then it would be something like that, where we have a strong likelihood of having decent solubility. That would be if there was going to be a prioritization for me, that would be it.
So this compound here has about an order of magnitude better solubility than all of the others. In fact, both of these ortho-substituted compounds here.
Oh, really?
The issue is that I've never been able to get the alkylation to go smoothly with these compounds.
Right.
I was also going to say those are interesting because that's basically the only modification we've seen to that 2-pyridyl that gives us any sort of potency.
These compounds here with the ortho substitution.
Yeah, just substituting off of it.
Okay.
Yeah.
Substitution of the main core kills potency, but substitution of the pyridyl functionality is allowed.
And so of these, Quillon, which do you think would be more straightforward for the alkylation reaction?
I mean, as a general rule, not these ortho-substituted compounds. As a secondary rule, when you start to load both the core and the pyridyl component up with electron donating functionalities, as you said, the basicity goes up, which means you tend to get a lot more of the byproduct of the pyridyl and alkylation.
Okay.
In theory, that should be reversible. So if we left it long enough and gave it enough heat, it should sort of act like DMAP, where you're sort of making a more reactive alkylating reagent.
Yeah.
But in practice, I haven't been able to get clean conversion for any compound that has like too much electron donating. So these compounds down here are a bit of a nightmare.
Right.
But in saying that, they're all possible with exception of these two.
The methoxy on the core has been shown to kill potency, so it would be interesting. The paramethoxy on the pyridyl, that's interesting because we've only had ortho substituted pyridyls.
No. Okay. So the let me just go back to the SAR stuff. So I think the issue with the methoxy on the core is a tox issue, not a potency issue. And the substitution on the 2-pyridyl we've had, sorry, I'm just trying to find it. We've had the paramethoxy, we haven't looked at the ortho or the meta yet. This is relative to that ring nitrogen. which,
I'm reversed in my head, I guess.
yeah.
Yeah, the meta is actually one of the ones on the whole list.
Yeah.
So that second row, third one in from the left would be one that we should think about alkylating. And actually, it does say H or methyl. So, I mean, I don't know if you actually do want to test the H.
I think that, well, for the sake of completing the SAR table, it doesn't have to be alkylated. Now, for the question of whether it's going to be potent against MRSA, I think we've
Needs to
shown
be
that
the
it probably is going to be more potent if it's alkylated.
Yep. I mean, we could probably just take 2 mgs out though and then alkylate.
Yeah, we could try both.
That would be really good. Yeah. And the amide in the bottom in the middle, if that's available. I mean, I guess it's just that, you know, an SAR hole we didn't realize we had.
Which one is, yeah.
It was completely dead for us, and I'm from memory chomped immediately, but it did have slightly better solubility.
Okay, in the interest of time, could I just suggest that Dana, because you have this series in your head with great freshness, would you be able just to correspond with Quillon and decide, and Laurie obviously, decide on a list of compounds that you think is best and reasonable?
Yeah,
that would be really tremendous.
Yeah.
Because I think all of these will be really nice, and I just want to make sure we're picking, you know, a small number that will cover a bunch of holes, and you know, we're choosing the compounds that we think are going to be either filling holes or most potent.
Okay, yes, I can do that.
Fantastic, really good. Okay, thank you, Quillon. That's fantastic. We're only got a few more minutes, and I just wanted to highlight one thing that you've been doing, Chris, on the machine, the discoverability of the data.
Yeah.
So you forwarded something to me, which I'll share, which is this guy. All right, do you want to explain what's happened here?
Okay, so I took or wrote a script which extracts all the data from the Google sheet that we have, and then uses RDKit to create the images of the structures, and then outputs that to an HTML page. So this is just a static page, which hopefully Google will index. The question is, what information do you want on this page? The question, I guess, is, okay, this allows people to find that these structures exist, but as it stands, it doesn't really help them find out more information about them.
Yeah, so I mean, the great thing is, of course, that because the smiles are there and all the other strings are there, that it can be found on Google. So you imagine you put the molecule in, and you say, I wonder if anyone's made this, and it takes you to this page, and you go, oh, that's interesting. Where is it? So you need another link somewhere to more information. Now, of course, with some of these things, we do have that, right? We've got the wiki link, and that presumably comes from our original spreadsheet.
Yeah.
So if we do our original spreadsheet better, then those links will appear there.
Correct.
So that's the answer, isn't it? We've got to get our house in order, and provide a link such that the interested chemist knows what's going on here. Is there a way of including something so that at the top of this page there is like a little nano README? I mean, if we had a cell at the top of our OSA sheet with that information, would that information come through to here?
No, you can't do that, because the first row has to be the column headers.
Right. Yeah. Yeah. Okay. And you can't have entry 0 being README.
I could experiment with that. I don't know.
Okay. Okay. Because that, I mean, that is neat, and that is so. This is where the wizardry thing comes in, because I have absolutely no idea how you're doing any of this, but this is something which happens when you run something, but could be set to be running automatically.
That is the plan, yeah. So the script is written, and at the moment it has to be activated by hand.
And it's on your computer?
It is, yes, but I could set it up as what is described as a cron job, so it happens at regular intervals, say once a week or something like this would run and generate a new file.
And then that's posted here, and that's obviously hosted on GitHub.
Yes, it's actually in the Mer ligase wiki or documents folder.
Right. So that will just sit there.
Yeah.
If your computer blows up, then it will stop doing that, but it won't change the page.
That's correct. Yes. I mean, the script is relatively straightforward. The only thing is it relies on RDKit to actually generate structures and things. But it works. The script could sit anywhere.
Right. I mean, that is a neat solution. This is already online, right?
Yeah. So what I'm hoping is that Google also index the images, which is why I put them in there. So when people search for a particular string or something like this, or identifier,
Right.
they may even find Google Images shows them the structure.
Yeah, that's neat. Okay. Would you be happy in I don't know, a day or something, or a week to check whether Google is seeing this?
Yes, I can do that. Yeah.
That is really a really neat solution, I think. We don't have time to talk about this now, but I guess one of the questions we had last time was whether or not the CDD vault stuff that you guys have at Northeastern, if you've got any of that set to public, whether that's indexed by Google.
I haven't had a chance to have a look, sorry.
No worries. It's a residual interesting question for me. I think I guess the answer is going to be no, but it would be great to try it out. So pick something in one of your CDD vaults that you know is unique to your CDD vault, and one which is public, obviously, and see whether or not it can be found.
Yeah, we'll have a play around today.
Cool. All right, great. All right, thanks. Just in the interest of time, that's all I've got time for, I'm afraid. But was there anything else anyone wanted to raise quickly?
Nope.
Right.
The admin compounds, I guess we can probably discuss that next week.
Yeah, okay, that's fine. Yeah, let's dedicate some time to that next time.
Okay.
All right, thanks so much. Really great to see everybody. Take care.
Bye.